Cloud Workspace Management Suite, known as CWMS, is a SaaS-based RDS, VDI, and Windows Virtual Desktop deployment, management, and orchestration tool. This platform is designed to simplify and expedite the process of delivering hosted cloud workspaces in virtually any hosting environment, including Azure, Google, AWS, US Signal, VMware, and Hyper-V. Once deployed, one major benefit is the normal day-to-day management can be handled within CWMS, limiting the level of Active Directory and hypervisor permissions required for help desk staff to do their jobs. Conceptually, there are two components that go into delivering a usable working environment for end users. First, the domain structure, gateway servers, and management components need to be built. Collectively, we call this the platform or software-defined data center, abbreviated SDDC. The second component is the tenant VMs that users will directly use, such as terminal servers, database servers, and application servers. Collectively, we'll call these machines the tenant or workspace environment. Deploying the SDDC is an automated process in Azure. In other environments, there are varying levels of manual work required, so in this example, we'll walk through the Azure deployment. We'll use the CWA setup wizard to make some decisions about the environment, such as the Azure region, the type of Active Directory setup, and several other important decisions. For an in-depth demo, look for the video titled CloudJumper SDDC and Tenant Overview on our YouTube page. The automated deployment process takes a couple of hours, but once complete, a brand new SDDC will have been built from scratch in your selected Azure subscription. All the best practices for cloud workspaces will be pre-configured, and you'll be ready to deploy the tenant environment. Within the tenant environment, you'll host user sessions on multi-user session hosts, such as terminal servers or Windows 10 multi-user VMs, and/or user-dedicated session hosts, such as VDI or Windows Virtual Desktop VMs. Optionally, the tenant environment can also include non-session hosting servers, such as application servers, database servers, and file servers, depending on the end user's needs. Adding the client is as simple as navigating to the Workspaces section of CWMS and clicking New Workspace. This starts a wizard where you'll add the client entity and optionally make some security setting decisions. You'll select the operating system of the first server to be deployed in this tenant. Other servers can be built later. You'll select the provisioning collection. A default single server collection is built with the SDDC automation. The default provisioning collection works well for nearly all environments, but provisioning collections are available and allow service providers to build customized environments that can be deployed over and over, saving time on setup and configuration for each tenant. On this page, you'll also select any apps and app services that the environment needs. Like most other settings, this can also be defined later. On the next page, you'll add a user. More can be added later, but you'll want to start with at least one. Then we'll click Provision, and a set of automated steps will build the tenant environment from scratch in an hour or two. Once completed, you'll have a brand new Cloud Workspace environment ready for apps, data, users, and further customization. First, we'll take a look at managing applications. There is a global app catalog you can manage by navigating to the Settings page by clicking on your username in the upper right. The catalog is simply a list of applications available to any of your tenants. Later, we'll attach these applications to tenants and users, and optionally attach automation to deploy and remove these apps automatically. Applications are deployed to the tenant environment in the Workspaces section under Apps. You'll add any catalog apps to the tenant with a checkbox. If automation has been linked to the app deployment, CWMS will automatically run the scripts that you've defined to deploy these applications across all machines that should receive it in the environment. For an in-depth demo, look at the video titled CloudJumper Scripting Overview on our YouTube page. For non-automated applications, you'll receive a service board item to manually resolve. You'll click on the service board entry and click Connect to log into the target machine or machines as a local admin and manually install the application. Then you'll log off and return to the service board entry. You'll browse to the location of the shortcut of the newly installed app and close out that service board entry. Now, with the app catalog item added to the tenant and installed on the servers, either manually or via automation, you can assign the application to the user individually or as a group. Assigning an app to a user individually is accomplished in the Workspaces section by clicking on the application and checking the box next to each user that needs the app. Alternatively, you can click on Users and Groups and assign an application or several applications to a group of users or to an individual. CWMS will manage delivering the shortcut to the users you select. You can also optionally enable App Locker, and CWMS will manage the permissions so that users cannot run applications they have not been explicitly granted, providing a stronger layer of security. Applications can also be delivered as a streaming app without the hosted desktop experience. Both desktops and streaming app delivery can be offered from the same tenant environment. CWMS manages the setup and delivery of this functionality simply by enabling remote app access for the tenant and for the application. Then any user who has the remote app enabled app can choose between a desktop and a streaming app when logging in. Next, we'll discuss how user and company data is handled. By default, the first server deployed will be both a terminal server and a file server. This is designated by the naming convention as a company code followed by TSD1. CWMS can convert this machine to a non-session hosting machine if the requirements of this tenant don't require a terminal server. For example, an all VDI environment where each user has a dedicated VM and/or a server needs to be dedicated to apps or database and should not also host user sessions. Simply click Convert to Data to change from a terminal server data server to a dedicated data server. Regardless of where the file server role ultimately sits, CWMS will automatically map user profiles and the company share from that location. Each user will have mapped drives for their company share and their individual desktop and documents. For an in-depth demo of the end-user experience, look for the playlist titled User Connection Methods on our YouTube page. End-user permissions for the company share can also be managed and enforced from CWMS. All from within this web portal, you can create and delete folders, create and edit user groups, and edit permissions for users and groups. Next, we'll look at user settings. First, we'll import additional users individually, in bulk via a spreadsheet upload, or automatically from Azure AD. For users that are already in AD but without a cloud workspace, you can simply click Enable Cloud Workspace. From there, CWMS will handle all Active Directory and provisioning actions required to allow this user to connect to a new individualized cloud workspace. Users can be moved back and forth from a shared user session, such as a terminal server, to a dedicated VDI machine under User Settings. CWMS automates all of the Active Directory and RDS setting changes required so that user will simply land on the appropriate session machine. If that change requires a new VM, CWMS will automatically build that virtual machine. User passwords and application assignments can be managed from here as well. Finally, we'll look at some of the tenant-wide customizations available in CWMS. When viewing a workspace, you can enable or disable remote app streaming, App Locker for increased app access security, app monitoring to track how often applications are accessed, local printing, the user profile disks as opposed to roaming profiles, cloud user data storage, the task manager visibility. There are also a few security settings that can be defined tenant-wide, including forcing password complexity, enabling file access auditing to see who accesses which files and when, temporarily disabling user inactivity timeouts for 1 week to assist with data migrations, and forcing MFA on all users in the environment versus enabling it on a user-by-user basis. Next, we'll look at VM resources. CWMS has the ability to change the size of virtual machines based on the real-world criteria and implement those during a nightly intelligent reboot window. For example, session hosts can be sized on the number of active users over the previous 2 weeks, with RAM and CPU quantities calculated dynamically. You can also set the maximum RAM and vCPU cores so that CWMS will clone additional session servers and scale horizontally, rather than growing a single VM larger and larger. The second is a fixed VM size pulled from Azure APIs. In the third option, the server's CPU load can be tracked over the previous 2 weeks and used to determine the size of the VM. And finally, the VM size can be defined by the total number of named users in the environment, similar to the active user setting, but without tracking typical active user loads. Similar settings can be assigned to the data servers and individual user VMs. Workload scheduling covers cost-saving features included in CWMS. Live scaling turns terminal servers on and off based on the number of user sessions. Thus, only a single VM will run 24/7 and additional servers will power on as the user session thresholds are exceeded. This functionality can easily reduce the compute costs for terminal servers by 50%. For an in-depth demo, look for the video titled CloudJumper Live Scaling Illustration and Demo on our YouTube page. Workload Schedule turns the entire environment on and off in a predefined schedule. Terminal servers, VDI machines, database and app servers all turn off, saving the most money during downtime. Schedules can be defined to be as granular as an individual on and off time for each day of the week. For an in-depth demo, look for the video titled CloudJumper Workload Scheduling Illustration on our YouTube page. The workload schedule feature can be combined with live scaling to only activate a subset of machines when turning on. This feature can also be combined with our patented Wake on Demand feature that wakes the environment up when selected users attempt to connect outside of normal hours. For an in-depth demo, look for the video titled CloudJumper Wake on Demand on our YouTube page. That concludes our quick CWMS demo. We've skimmed past many efficiency-gaining features and unique use cases. Please reach out to our team for a personalized conversation and demo, and for more information, find us at www.cloudjumper.com.